Welcome to a deep dive into the world of small language models. Well, more specifically, the development of SmolLM2. You sent over some fascinating research on this, and I think you'll be really surprised by what these compact models can accomplish.
It really is remarkable to see how researchers are pushing the boundaries
Uh,
of what's possible with smaller models, especially when resources might be limited.
yeah, we've got excerpts from the research paper, SmolLM2, when Smol goes big, and even the abstract highlights how data is just absolutely crucial. They trained this 1.7 billion parameter model on a massive 11 trillion token data set. It's a staggering amount of text.
Yeah, and the researchers went beyond just using any available data. They were incredibly selective about the
Yeah.
quality and composition of the data used to train SmolLM2.
Interesting. So they actually tested a wide range of web, code, and math data sets, but they weren't satisfied with what they found.
Yeah, they found that. Existing datasets were often too small or lacked the kind of step-by-step reasoning examples that are crucial for training a model to understand complex concepts, particularly in mathematics.
Okay, so they did something pretty remarkable. They created their own data sets, FineMath for concentrated math content, and Stack-Edu for code, meticulously filtered for educational value. Imagine being that discerning about your training data.
The results were really quite striking. FineMath, for instance, significantly outperformed other open math datasets on benchmarks like GSM-8K, which is a challenging math reasoning test. Hell, they saw a twofold improvement in some cases.
That's incredible. And it gets even more interesting. Instead of just using one massive data set, they took a multi-stage approach, carefully adjusting the data mix at each stage to address specific performance bottlenecks.
Yeah, this allowed them to start with a broad base of web text and then gradually introduce code and math data, culminating in an annealing phase with their highest quality data sets. They even extended the context length from 2,000 to 8,000 tokens, which opens up interesting possibilities for tasks that involve longer pieces of text.
And they didn't stop there. They also incorporated instruction tuning and preference learning, using a custom-designed data set called SmolTalk to further refine the model's ability to follow instructions and provide helpful responses.
SmolTalk is really important because it contains examples of system prompts and function calling, making the model more adaptable to real-world scenarios where it needs to interact with different systems.
Yeah.
Um,
They really put a lot of thought into how to get the most out of a smaller model.
yeah, the researchers focus on data quality. It highlights how important it is to train these models on the right kind of information.
Let's take a closer look at those custom data sets they created. FineMath seems particularly interesting, especially given how challenging it is to train language models to reason mathematically.
They recognize that existing math datasets were often inadequate for teaching a model the kind of step-by-step reasoning required for solving those complex math problems.
So it's like no track.
Yeah.
They want a SmolLM2 to have a solid understanding of the underlying mathematical concepts, not just memorize formulas.
To achieve this, they used a classifier, trained on annotations from a larger language model, to identify high-quality math content from the Common Crawl dataset, focusing specifically on URLs from the FineWeb dataset. This helped them extract content that emphasized deduction and reasoning.
And Stack-Edu for code. That's another impressive effort.
They?
Try to cover every programming language out there.
They're focused on the 15 most popular programming languages, recognizing that a smaller model might not need to learn every obscure language. The key was to ensure that SmolLM2 was learning from well-documented educational code examples.
It's about quality over quantity again.
They used language-specific classifiers to identify code that was not only functional, but also clear and easy to understand, like providing the model with a collection of well-written programming textbooks.
Okay, now let's talk about SmolTalk. It seems like this data set was specifically designed to make the model more interactive and user-friendly.
SmolTalk was crucial for the post-training phase, where they focused on refining the model's ability to follow instructions and provide helpful responses. They combined existing data sets with new synthetic data to cover a wide range of tasks and instructions.
Did they include things like multi-turn conversations, which are so important for natural language interaction?
Yes, they incorporated data from multi-turn conversations, specific constraints, summarization, even examples of system prompts and function calling. They also included math data from datasets like NumanaMath.Co and MetaMath.QA, which are known for their strength in different areas of math reasoning.
It sounds like they really tried to anticipate
Yeah.
the different ways someone might interact with the model and ensure that it could handle those interactions gracefully.
Yeah. The development of these three datasets, FineMath, Stack-Edu, and SmolTalk, is a significant contribution in itself, providing valuable resources for other researchers working on small language models, and highlight the importance of carefully crafted training data.
They've got these amazing data sets. Now, how did they actually go about training SmolLM2? The paper mentions a multi-stage approach.
Yeah, the training process was carefully designed to maximize the model's learning potential. They began with a stable phase, consisting of three distinct stages.
What was the focus of the first stage?
The initial stage was all about laying a solid foundation. They used a mix of web text data, 60% FineWeb and 40% DCLM, to provide a balance of educational content and diverse real-world examples.
And I'm guessing they also incorporated some code data at this point.
They included code data from StarCoder data, but they held off on introducing math data until later stages. The idea was to build up the model's core language and coding abilities before tackling the complexities of mathematics.
So they were being very strategic about the order in which they introduced different types of data. What about the second stage?
In the second stage, they started to address specific performance bottlenecks. They introduced the Open Web Math dataset and increased the proportion of code data. This was aimed at improving the model's coding and mathematical reasoning skills, while retaining the strong knowledge and reasoning abilities from the first stage.
Did they see significant improvements in math performance with the addition of Open Web Math?
While they observed improvements in code performance, the addition of Open Web Math didn't have a substantial impact on math performance. This highlighted the need for even larger and higher quality math datasets, which they incorporated in later stages.
It makes sense that they would need to be quite selective.
About the math data, given how nuanced and complex mathematical reasoning can be.
During this stage, they also made an interesting observation about the model's performance. On the MMLU benchmark, it was achieving above random accuracy with a multiple choice formulation, which is unusual for a model of this size. So even at this stage, there were hints that SmolLM2 might be capable of abilities usually associated with much larger models.
In the third and final stage of the stable phase, they introduced even more data sources, including the text portion of InFiem Web Math, Stack-Edu for code, replacing StarCoder data, and Jupyter Notebooks from StarCoder 2.
It sounds like they were really trying to provide a rich and diverse set of examples for the model to learn from.
Yeah. And they also adjusted the mix of FineWeb and DCLM based on their findings from the previous stages. This constant refinement and tweaking of the data mix highlights their commitment to finding the optimal balance for SmolLM2's development.
So they were continually learning and adapting their approach based on the model's performance, like a feedback loop where they're constantly trying to improve the training process.
They did encounter
Yeah.
a challenge during the stage in the form of a loss spike. The cause of this spike isn't entirely clear, but the model did recover by the end of the stage. It's a reminder that even with meticulous planning, there can be unexpected hurdles in the world of AI research.
Okay, so they've gone through these three stages of the stable phase, laying a strong foundation and addressing initial performance bottlenecks. What happens next?
The final stage of training is what they called the decay phase. This phase was all about refining the model's capabilities and pushing its performance to the limit.
What kind of data did they use in this phase?
They introduced their highest quality math datasets in FineMath 3+ and FineMath 4+ neg. They also expanded the range of programming languages included in Stack-Edu.
So they were really focusing on those areas where they wanted to see the most improvement.
They continued to emphasize the importance of DCLM, maintaining a higher proportion compared to FineWeb.
Seems like DCLM played a significant role throughout the training process.
They also introduced a dataset called Cosmopedia V2, which contains synthetic textbooks, blog posts, and stories. This added another layer of richness and diversity to the data mix.
With all of these carefully selected data sets in this multi-stage training approach, I'm guessing they started to see some pretty impressive results.
The decay phase resulted in significant gains in both coding and math performance. This validates their decision to prioritize these areas and really push the model's capabilities in the final stage of training.
But they didn't stop there.
They took on the challenge of extending SmolLM2's context length from 2,000 to 8,000 tokens.
What did that involve?
They continued training the model with a mix of data that included longer documents, which enabled it to handle tasks that require a broader understanding of context.
Okay. This opens up a lot of possibilities for SmolLM2. What came next?
Post-training. And this is where SmolTalk, their custom data set, became really critical. It was really instrumental in fine-tuning the model's ability to follow instructions and provide more helpful responses.
SmolTalk really helped make SmolLM2 more interactive and user-friendly. What was so special about this dataset?
It brought together a really wide range of data sources, including multi-turn conversations, specific constraints, summarization examples, system prompts, and function calling. This ensured SmolLM2 could adapt to different use cases.
It sounds like they were preparing it for real-world interactions. How did they evaluate SmolLM2's performance after all of this?
They assessed both the base and instruct versions of the model. They compared them with other state-of-the-art models of similar size, specifically Qwen2.5-1.5B and Llama3.2-1B.
So they wanted to see how SmolLM2 stacked up against the competition. What benchmarks did they use for the base model?
They used a variety of benchmarks that tested knowledge, reasoning, math, and code generation. The results were quite compelling.
How did SmolLM2 perform?
Well, SmolLM2 outperformed Qwen2.5 on several benchmarks, including HelloSwag and ARC. It even showed strong performance on benchmarks that hadn't been specifically trained on, like MMLU Pro and Trivia QA.
That's a good sign. It suggests that SmolLM2 can generalize its knowledge to new situations. What about its performance on math and coding benchmarks?
While SmolLM2 lagged behind Qwen2.5 on some of those, it consistently outperformed Llama3.2-1.2-1. This really demonstrates the impact of their careful data selection and multi-stage training approach.
How about the instruct version? SmolLM2 instruct, what benchmarks did they use for that?
They focused on benchmarks that specifically evaluate a model's ability to follow instructions and engage in conversations, including ifeval, mtbench, and open rewrite evil.
How did SmolLM2 instruct perform on these?
It significantly outperformed Qwen2.5-1.5B instruct on ifeval, and it also did well on mtbench and open rewrite evil. Additionally, it demonstrated strong performance on math benchmarks such as GSM8K and math.
It sounds like SmolLM2 instruct really excelled in that domain. The researchers behind SmolLM2 have done some really impressive work here. They pushed the boundaries of what's possible with smaller language models, and they've made significant contributions to the research community by releasing SmolLM2 and their datasets publicly.
Their work provides valuable insights into the importance of data quality and training strategies. For smaller language models, this is certainly a fascinating area of research. I'm eager to see what they do next.
This deep dive into SmolLM2 has been incredibly informative. We've learned a lot about these compact, yet powerful models. Thanks for joining us. Until next time.